A body simultaneously rotating about more than one axis often scares a student preparing for IIT-JEE. The goal is tended to solve such problem is to use inertia tensor. But IIT-JEE expect that you should solve such question using the concept available at 10 plus 2 level. So here I have a very beautiful problem from Irodov 1.267. I need not read the question. The diagram is self-explanatory. This is solid sphere, mass m, radius r, small r. The motion is mimicking the motion of Earth. The Earth revolves around the Sun like this, and it also spins around this axis. The angular velocity of the two are at some angle. That is, I think around say 23 and a half, something like that. But here, what is happening that if you see that this sphere is center mass of this sphere is revolving, or a better word would be the orbiting in this horizontal circle, and this body is rolling without slipping on this horizontal surface. So it has a two angular velocities. The circle at which the lowest point is stressing the circle on the horizontal surface has a radius capital R, and it has a radius small r. What is given in the question is that the velocity of the center mass of this solid sphere is v. So we have to find the uh, kinetic energy of this solid sphere. So first of all, let's see the kinematics part. As I explained that it has a two angular velocity, one of that, like you see that its center mass has a velocity something like this v is in this plane, and the center mass is revolving like this, or better I had said the orbiting. So it has an orbital angular momentum. That orbital angular momentum is in this direction, and we write this orbital angular momentum as say omega o, and this is the axis about which this body is spinning. So this is axis, I can expand it, is spinning along this axis. So the one angular velocity is like this, another angular velocity is here, and let me write this angular velocity as say some omega s. Omega s is the spin angular velocity, and these two angular velocities are not independent because this is rolling without slipping. So I need to find the total kinetic energy. So what we will do, I will like to find its IUR. Why I want to IUR? Because from IUR, if I see kinetic energy, I can simply write total kinetic energy of this solid sphere is nothing but half. From the IUR, if you see any body, if it is doing CTRM, combined translation and rotation, from IUR the motion appears to be pure rotational. And in pure rotational motion, you know that the kinetic energy is half I omega square. So I want to look the whole picture from IUR, and if moment of inertia from IUR is IUR and then omega square. But now question is that which omega? This omega or some other omega? That omega should be the net omega. Net omega is always along IUR because angular momentum is a vector quantity. So if you add two vectors, you will get the resultant vector. So the resultant angular velocity of the this body doing CTRM and the body having more than one omega. So the resultant omega is the vector sum of all the individual omegas. So its resultant omega will be along this direction, but that will not be independent. These two will be related by a relation, and I will show. So if the omega net is, we can find omega net. So kinetic energy would be half I about IUR into omega net square. So now let's try to find out its IUR. To find IUR, because we know that when you see that somebody is doing a pure rotational motion, so from IUR the motion appears to be pure rotational, and that in IUR the axis is fixed. So any point on the fixed axis has a zero velocity. So if either you have body, complete body, or if body is not there at the point, to extend that body. So if you can find 2 points on the body or on the extension of the body whose velocities are zero, then the IUR must be passing through that point, through those 2 points. So this is the body, and I can think that this is the extension of this body because this whole system is a result system. So this point has a zero velocity because this whole system is rotating about this. This is spinning about this line, and this point, the point of contact on the ground, has to be zero velocity because it is rolling without slipping. So there is no relative velocity, ground has no velocity. So this point of this rolling sphere has to have zero velocity. So my IUR must be passing, IUR must be a line which is passing through these 2 points. So IUR would be something like this. If I draw a line from here to here, and that should be my IUR, like this. This is IUR. This is IUR, like this. This is IUR, IAOR. And the net angular velocity must be along this direction. So if this is omega net, so omega S and omega O has to be related in a way that this is omega O orbital, this is omega S spin, and this is omega net. So they have to be related by a certain relation. Suppose this angle is theta, or this angle is theta. So if I want to use omega S, I can say that omega S is omega net cos theta, or I can also say that omega O is omega net sin theta. So one relation I am going to write about omega S. Omega S is equal to omega net cos theta, and omega O I want to write omega net sin theta. And see what is omega S. You look this point, from here to here distance is capital R, and you see the orbital angular velocity, it is moving with this center mass is moving this velocity, this distance is R. So this omega O must be V by capital R. Omega O must be V by capital R. And similarly, if you look from here and it is spinning like this, so from here the distance is smaller. So this velocity V, or this omega S, can also be written as V by small r. So this is omega S is V by small r, and resultant omega, I can find the square root of omega S square plus omega O square, or simply I want to use omega S. So omega net I want to write from here V by small r. I am using this relation, V by small r sec theta. That is my kind of equation 1. Now, and you see that here, from here, if you need, you should have this relation handy, like tan theta. Here tan theta is how much? Tan theta is equal to I by capital R. The only thing you need to find out is I about IOR. So for finding moment of inertia about this IOR, what you need to know, you need to do a parallel axis theorem. So draw an axis parallel to IOR, and that axis is one axis passing through center mass, and this axis parallel to IOR. Passing through center mass, any axis passing through center mass is along a diameter. So about this axis, suppose moment of inertia is IC. This is a diameter practically. So you know that about diameter, moment of inertia of solid sphere is 2 by 5 mr square. And if the perpendicular distance between these two axes, this is how much? This is a small r, and this is the perpendicular distance. This distance let me call d. See that this is theta, this is 90 minus theta, and this is again theta. So d is equal to how much? D is equal to r cos theta. I think this is clear in the diagram. So moment of inertia about IAOR should be I about C plus md square. And I about C, I'm writing 2 by 5 mr square, and this is m and r square cos square theta. So take mr square common, 2 by 5 plus cos square theta. So put it here. Net kinetic energy K is equal to half I about I over I am writing mr square 2 by 5 plus cos square theta and v square, sorry, omega net square. Omega net square is this. How much is that? V square by r square and sec square theta. So this r square will get cancelled. So here you will get mv square by 2. Take sec square inside the bracket. So this sec square theta into cos square theta will become 1, and that will be 2 by 5 sec square theta. And now coming to here, come up to here. So this thing, this is this extension of this, so that will be mv square by 2, 1 plus 2 by 5. Sec square theta is equal to 1 plus tan square theta. So just put it, 1 plus tan square theta mean 2 by 5, and tan square theta mean you will have to write tan square theta from here, small r square by capital R square. So that thing. So that will become how much? mv square by 2, 7 by 5 plus 2 by 5 small r square by capital R square. I want to take 7 by 5 outside. So if I take 7 by 5 outside, that will become 7 mv square by 10, and here 1. And how much if I take 7 by 5 outside? That should become 2 by 7. This is how much? 7 7 cancel, 2 by 10 when this is 2 by 10. R square by capital R square, and this is our expression. This thing is the total kinetic energy of this body which is spinning and revolving simultaneously. So I have used the approach using IOR, and this is a purely an approach that one can use at IIT-JEE level without using the fancy concept of inertia tensor. Hope this like this. Stay tuned for such videos. Thank you.